Today's businesses face increasing pressure to transition to becoming digital enterprises. Systems engineers are tasked with facilitating this hugely complex endeavor. But how do we go about developing the next generation of systems engineers? We asked some professors of systems engineering for their thoughts.
So my name is Air Force Lieutenant Colonel Dr. Moshe Ayal. I'm the founder and first head of the Systems Engineering Department in Afeka, Tel Aviv College of Engineering in Israel.
So hello everyone, I'm Amy Thompson. I'm a professor of systems engineering at the University of Connecticut. I coordinate and lead our systems engineering education programs for UConn's UTC Institute for Advanced Systems Engineering. And I serve as the Institute's Associate Director.
My name is Jim Long, and I'm an Associate Professor of Engineering at Liberty University in Lynchburg, Virginia. And I primarily oversee the first year engineering program, although I'm also heavily involved in the senior design capstone sequence.
First, we ask these leaders what they see as some of the challenges that exist to developing the next generation of systems engineers.
Some of the challenges I find when teaching students systems engineering is that a lot of it has to do with that there's a digital transformation taking place. And this transformation involves connecting information and data in more complex ways.
I just think digital is absolutely going to be essential to the future of things that need to be developed and designed in the world. Well, I think it's really important when it comes to digital engineering to realize that we're beyond the days where you can have an idea and go out in your garage and tinker with it for a while and come up with something that works, and then begin to think about, the analysis part of it or the modeling part of it. And I think more and more the challenges that we face as an engineering discipline over the coming years are so great and will require so much more collaboration that digital tools are really kind of like the key to being able to really pull off the major design developments that are on the horizon.
We cannot tolerate implicit any longer, and unfortunately, colleagues still teach document-based systems engineering using Visio and the like. And probably it's easier to do in class, but how do you simulate effectively? How do you integrate? How do you test or verify? Eventually, they all move to model-based systems engineering rather than the legacy document systems engineering.
One thing I'll say about this is about systems engineering is, there's a very deep focus on the technical aspects in developing the models, and that is important to learn that. But we can't forget about the people in the loop and the human integration with our systems. And sometimes that's even more challenging to model than our engineered systems. So, we can't forget about considering social and societal impacts, as we increase the speed of technology development as a result of this digital transformation. And we need to make sure humans still integrate with our systems and that they can understand and can monitor their behaviors, their operations and results.
How do you teach systems engineering today?
So one of the key components of our systems engineering program design is to focus on learning systems engineering through experience. And we use a project-based approach to teaching in all of our graduate level systems engineering course. When we do systems engineering well at the process and management level, then we have the ability to break down silos of engineering disciplines at the systems level, and we can achieve new levels of collaboration. And through this collaboration, we can invent and create new ideas and new solutions.
They go into the lab, they build projects and then they are able to use the tools as in real life. Actually, they have the material, they have the substance, they have the functionality, they have the tools. So we just try to create the environment as if they were now working in industry. I find Genesis and previously Core very helpful in my teaching in my curricula in systems engineering and courses. This is because our whole agenda is about model-based systems engineering. The fact that you go systematically from documents, from memorandums, to requirements, to functions, to components, and ultimately to test, verification, and the like.
The more you know about the digital tools, the better. And the idea of working through the solution in a way that exercises the things that we know and doing the analyses, applying things like all the codes and standards, which are easily captured digitally. And now with a model-based approach, it's much more likely that we're going to be able to accommodate the requirements of the stakeholder and the institutions who levy the standards and requirements, and combining that with the analytical side of things that are necessary.
You know, one of the really neat things about Vitek Genesis is that you can actually create a systems model just understanding the systems engineering classes and the relations between the classes. And so, you know, you can actually, to me, it's kind of a true way of teaching model-based systems engineering before jumping into something like SysML, the modeling language, because you can go into Vitek Genesis and create your classes and define the relations between them. And then Vitek Genesis actually automatically creates the SysML diagrams for you. It's almost like an AI.
We wanted to know if students realized the value of their formal training in systems engineering once they had gotten into their careers. So we asked the teachers if any of their students ever came back to tell them it had made a difference.
There have been students who have come through our program and they've gotten jobs working with industries that do a lot of DoD and other government type work where systems engineering is the name of the game. And so I have had students who have told me that they've been able to utilize what they have learned in our courses. And I think they realize that being able to say that they're familiar with the processes involved and they're familiar with model-based systems engineering and they're familiar with a tool like Genesis, I'm sure that people are putting that on their resumes as things that they know and can do.
It's really nice to hear back from students 2 or 3 years later, because sometimes you really don't understand the impact until you apply it in your job and you get the chance to work as a systems engineer and get to apply it and you think, oh, I'm really glad I learned this. It's really helpful in my career. We definitely hear that as a lot of students come into our program at the graduate level because they know long-term they want to go into systems engineering. They may come as a mechanical engineer or electrical engineer or computer scientist, and they know long-term they want to know how to design systems at the systems level. And so I think they're very excited many years later and they're like, oh, this helped me achieve my career goals.
If you'd like to learn more about Vitek's university program, visit vitekcorp.com/university-program or email universityprogram@vitekcorp.com.